நமதென்று சொல்லுவோம், நல்ல பாதையில் செல்லுவோம். கல்வியே கண்கள் என்றுமே புது தலைமுறை நாம் பெயர் சொல்லுமே.
Dr. NGR Educational and Research Institute, University, Motherable, Chennai.
Namaste and warm morning to all. On behalf of Faculty of Engineering and Technology, first year BTech, Dr. MGR Educational and Research Institute, University, I, Dr. Preeta George, with my co-host, Dr. B. Leda, feels immense pleasure to welcome you all to this webinar on quantum perception of solar cells. COVID-19 has pushed all of us to confine to the comfort of our cozy homes. But this sudden shift away from the classroom teaching and learning does not stop our quest to update our knowledge and skills. Web-based seminars and webinars are now part of our education. Education, a passport to the future. It belongs to those who prepare for it today. Here we have a person with her presence makes others to vibrate and her actions echoes louder than lioness. And it is the voice of our Dean, Dr. N.S. Shubhasri. May I request her to welcome and address the gathering.
Thank you, Dr. Preeta. So a warm good afternoon to one and all present for this occasion. So first of all, before giving a welcome note, I would thank our beloved President Sir for creating such opportunities and making the teaching learning process a more enhanced one. On behalf of first year BTech, I extend a warm welcome to our Vice Chancellor Madam, Provost, our Rector Sir, Registrar, Additional Registrar, all Joint Registrars, Directors, Deans, HODs, and all other executives of our university. I also extend a warm welcome to our chief guest, who was one among us, Dr. G. Mangalam. She was with us for a few years in MGR, so I think we have got a good memory and a good space to share. So she has given her concern, and today she is going to address all of us on quantum perspectives of solar cells. Once again, this is a topic that is relevant to the current scenario and trend, and it is also very much useful for the engineering and technology students. I welcome all the participants. I welcome the comparing team and the technical team supported by Ms. Aparna, Mr. Saravanan, and all other who have directly and indirectly supported this event. Opportunities don't happen, but you create them. Don't judge each day by the harvest you reap, but by the seeds that you plant. Yes, that is what we do exactly. Many may wonder, what is going to happen in first year, or why all this should happen. But today we are sowing the seeds with such events and such eminent personalities so that tomorrow you are ready for harvest. You are ready for harvest, you are going to face a world, you are going to take our MGR flag globally. All our students should be competent enough, they should be innovative, they should have an entrepreneurial mindset, and this is what is our motto. So today we have one such chief guest with us who is going to sow the seed and illuminate us. I welcome Dr. Mangalam ma'am. Thank you for coming, ma'am. And once again, I extend a warm welcome to all those who are present for this event. Thank you.
Thank you, ma'am. The most awaited moment to know about our guest has come. Even though she does not require an introduction, our portfolio does not allow to skip it. With great pride and joy, I like to inform you that she was one among us, part of our family, and who worked in MGR University for nearly 10 years. The days which we spent together in the campus of Dr. MGR University are beautiful memories for all of us. It can be rightly said, days are not lost when memories are created. But for our student community, certainly she needs an introduction, and I request Ms. Sapna from Department of ECE to introduce our guest to this beautiful audience.
Am I audible, ma'am?
Yes, ma'am. Yes, ma'am.
Yeah, thank you, Dr. Preeta, ma'am. A very happy morning to all. I'm very delightful to introduce our guest of the day, Dr.G. Mangalam, madam, Assistant Professor, Department of Physics, Pachaiyappa College, Chennai. Our guest qualifications are as follows. She has more than 25 years experience in teaching. She has completed her doctoral degree from the University of Madras in the year 2012. She got her MPhil degree from Azhappa University in the year 2000. She has completed B.Ed from Kamarajar University in the year 1996. She has completed her PG and UG degree from Kamarajar University in the year 1995 and 1993 respectively. She has published nearly 8 articles in highly reputed indexed journals, which has high impact factor, and has participated more than 10 seminars, conferences, and workshops. She is an organizing secretary and convener for many webinars, conferences, and workshops. She has guided more PG and UG students. She is expertise in several areas like crystal growth, quantum mechanics, optics, atomic physics, nuclear physics, etc. We are happy to have such an eminent person for today's webinar. I'm sure we will be enjoyed the today's event with full of knowledge. Once again, I welcome you, ma'am, for a wonderful webinar entitled Quantum Perceptions of Solar Cells. Thank you, ma'am. Over to Preeta, ma'am.
Thank you, Sopna, ma'am. Without any ado, let me request Dr. G. Mangalam to take us to the depth of quantum perception of solar cells.
Ma'am, sorry, ma'am, your mic is muted, ma'am. Can you please unmute, ma'am?
Sorry, I will start from the beginning. Thank you for this wonderful introduction. Okay, am I audible here? Am I audible? Am I audible now?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Thank you for this wonderful introduction. I feel immense pleasure in meeting all the faculty members after a long time. First of all, I would like to thank the founder of this reputed institution, Dr. A.C. Shanmugam, and our president, engineer A.C.S. Arun Kumar, and my dear friend and the Dean of Science, Subhashri, and all other executives for giving me this opportunity. Starting with our webinar, Quantum Perception of Solar Cell. Today is all about the uncovering facts and effective handling techniques of solar cell by quantum concepts. We would have come across solar cell while using lot of modern day-to-day appliances like solar calculator, solar watches, solar lamp, etc. To make this topic more interesting and also to understand the importance of solar cell, I would like to quickly go through some fun facts about solar cell. I will share the screen now. Would you all be able to see this?
Yes, ma'am. Yes, ma'am.
See here, solar cell. The fun fact about solar cell and solar energy. Solar energy is an abundant energy source. It can be produced without direct sunlight. Sun provides enough energy in 1 hour to power the planet for the whole year. Initial solar cell, the first commercial solar cell gives only 10% efficiency. Its cost have fallen 99%.
Mangalam ma'am, Mangalam ma'am, you can continue, ma'am. Yes, ma'am. Yes, ma'am. You can
ஆடிபிளா
continue.
இல்ல நாங்க ஆடிபிளா இல்லன்னு வந்தது.
Audible only.
Okay.
Press you just put the presentation mode, ma'am. Just press F5.
Okay. Is it okay now?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
The first commercial solar cell yields only 10% efficiency. Its cost now reduces 98% from 1977. NASA using this concept from 1956. Today we can achieve more than 20% efficiency. Solar power plant can last 40 years. China is the world leader in solar energy. Amui. எல்லாமே Rita audible?
Yes, ma'am. You are audible.
Audible தானே?
Yes, ma'am. You are audible. You just continue, ma'am.
Okay. Solar power plant can last 40 years. These are few fun facts about solar cell. Before going to our topic, see this picture. Let us take a first look at the first picture. Can you see light?
Mangalam ma'am, press F5. Zoom it. Presentation mode. Yeah. Yes, ma'am. Yes, ma'am. Thank you.
Can you see light? We can't, because we know that light is a form of energy. Any form of energy, we can only feel it. We can then what do we see? With the help of optical phenomena like reflection, refraction, interference, diffraction, and polarization, we are able to see the source of light. See here, we can see the source of light as sun, not exactly the light. See the next picture. What is the relation between the two pictures? What we conclude from the second picture? Someone would say that this second picture is a stone. Someone would say it is a god. actually we know that the second picture is a stone statue for God. From this, I can conclude one thing in Tamil standard proverb, Kalla Kanda Nayakana, Nayakanda Kalla Kana. Actually, that is, originally it is, Kallai Kandur Nayahane Kandadilli. That is the standard Tamil proverb. Kallai Kandur Nayahane Kandadilli. That is the dual nature. Similarly, the universe exists in matter and radiation form. There is a close parallelism between mechanics and optics. Mechanics gives the details about the matter. Optics gives the propagation and the properties of radiation. From this, the phenomena, optical phenomena. See here, the next picture, next slide. The optical phenomena like reflection can be explained in terms of waves. Similarly, it can also be explained in terms of particle. Refraction, same, like that of particle as well as wave nature. Interference explained only by wave nature. Diffraction only by wave nature. Polarization only by wave nature. The photoelectric effect, Compton effect, these phenomena explained by only by particle nature. So from this we can conclude that some of the optical phenomena explained by both the nature, some of the phenomena by only wave and particle nature alone. We can conclude that light has both particle as well as wave nature. Already I told that there is a close resemblance, similarities, analogy between optics and mechanics. So, the very old mechanics theory is nothing but classical mechanics. The classical mechanics predicts the trajectory of the particle, that is the particle nature of matter. If the particle has motion, any type of motion, translation, vibration, rotation, whatever may be the motion, there may be the continuum of energy states. But according to classical mechanics, particle nature and wave nature are distinguishable phenomena, like that of light. Light has dual nature, but particle nature is different, like wave nature is different. Similarly, classical mechanics also, these two natures are distinguishable phenomena. We know that by the particle nature, it possesses the property of mass, position, and velocity. Its behavior is momentum and collision. Similarly, wave nature, wavelength and frequency, its behavior, diffraction, interference phenomena. These classical concept, this distinguishable concept, could not be able to explain this black body radiation, photoelectric effect, Compton effect, specific capacity, etc. So, the rectification of these drawbacks only lead to the development of quantum mechanics. That is, we have to accept matter has both the nature, particle as well as wave nature. This dual nature only rectifies the drawbacks of classical mechanics. The next picture, see this picture? The first one, the girl cries. Nobody understands. Why? The quantum is also like that. The quantum says that don't worry, I am with you. See the next picture. What is that? A girl with different instruments or different objects in her hand. Nowadays, everyone says that nobody can understand a woman. Why? Because the woman has to act depending upon the situation, or depending upon the situation, she has to behave. Like that of quantum mechanics can't understand because it has to behave depending upon the situations. We can conclude that matter also has to behave in a dual way. Then the scientist de Broglie proposes his concept, particle behave as a wave. We say that as a matter waves or dual nature. Matter waves are nothing but material particle behave as a wave. This property was confirmed by Davis-German experiment. According to him, the particle behave as a wave. G.P. Thomson experiment, according to this experiment, wave behave as a particle. That is, electrons gives a current. Like this, there are so many experiments. confirms the dual nature of matters. So scientist De Broglie proposes some relation that gives the relation between momentum and the wavelength. And also he explains the particle nature in terms of wave function. See here, lambda is equal to h by p, where h is Planck's constant, p is the momentum. Our human mind won't accept anything easily. We need some mathematical proof. Our human brain will accept everything in a mathematical format. So, scientist Schrodinger derived an equation. According to him, he derived a mathematical equation, which is a second order differential equation. He gives explanation for that, why he derived the second order differential form. We know that particle moves in a straight line path. That is, particle has a rectilinear propagation. So due to this rectilinear propagation or a straight line path, we know the equation y is equal to mx plus c. This straight line equation is enough for particle propagation. So Newtonian mechanics or classical mechanics follow this concept, the rectilinear propagation of light. Then the wave concept, we know that light has wave nature also. The diffraction, interference can be explained only by the wave property. So if light behaves as a wave, it has to follow or it has to obey some equation. That equation should be in a not in a rectangular coordinate system. It may be in a angular coordinate, spherical polar coordinate, or cylindrical polar coordinate, like that. Some other coordinate system it should have. If the light has dual nature, then it has to obey the particle as well as wave nature. Then the equation has to satisfy both these nature. So the scientist Schrodinger derived the mathematical equation, second order differential equation. We call that as a wave equation. That equation explains the drawbacks of classical mechanics. So he derived the Schrodinger equation on two different concepts, time independent Schrodinger equation as well as time dependent Schrodinger equation. What is this time independent and time dependent equation? I'm not going to tell all the details about this time independent and dependent equation. Actually, I just give the significance of these two equations. Time independent equation is a stationary state wave function. That is, it gives a stationary state system. Time dependent equation, dynamical behavior of the particle. Those particles which changes with the time, which changes its momentum, energy, position with the time, that behavior can be explained by time dependent equation. So these two are fundamental equations in quantum mechanics. These concepts only led to the formation of quantum mechanics. Then postulates, the wave function concepts, whether the wave functions are orthogonal or orthonormal or simultaneous eigenfunctions, like this, so many concepts are formulated. Then Schrodinger applied his concept in so many physical problems. What is a physical problem? As per classical concept, we know that particle moves in a straight line. He derived equation for free particle moving in one dimension. Also, he applied this concept in different situations. That is, if the particle moves in a heavy potential, or if why can't the particle penetrate in the potential? Like this, so many physical problems he solved. Based on this, particle in a one-dimensional box, potential step, potential barrier, potential well, electron in an atom or molecule, harmonic oscillator. What are these things? What is the necessity of considering all these topics? I will tell it later, because as an engineering students, you know that how the electrons moves, how it produces current. This concept you know. So that concept can be explained, or that concept gives exact value how much current will be produced, how much voltage will be produced. That can be explained only by the physical application of Schrodinger equation. I will tell it later. See, these are the physical examples, how he solved physical applications also, how these Schrodinger equations are applied in physical situations. Cyclotron, see here, if the electrons moves or if the particle moves in a zero potential, then this concept is used for making cyclotron. If this electrons moves in a step potential, then it can be easy to calculate electron relieved from the surface, metal surface. Like that. I have given so many examples for the physical problems. Does it has a meaning in reality? Electronics, laser, fiber, material science, nanofield, etc. Like this, it has so many physical applications. The flourishing one is solar concept. Now, we will enter into our topic, quantum perception of solar cell. See here, solar cell. We know that solar cell is a photovoltaic device that converts light energy into electrical energy. What is its principle? Solar cell is based on the principle of photovoltaic effect. What is that photovoltaic effect? This photovoltaic effect is the photogeneration of charge carriers in light absorbing material as a result of absorption of light radiation. See this picture, photovoltaic effect is nothing but a PN junction diode, P-type and N-type material joined together. We know that it make a diode. When light energy made to fall on this PN junction, then it can produce a current or voltage. This is called as photovoltaic effect. Then what is the difference between solar cell and this photovoltaic cell or PV cell? In solar cell, solar energy is made to fall on the PN junction. But in PV cell, any form of light energy, even the tube light or whatever the other light sources, unspecified light sources, is used to produce the output voltage. Now let us move on to this topic in detail. How this quantum perception deals with the solar cell effectively. Basically, this concept explains our topic. Typical single solar cell produce 0.5 to 1 volt. Even 1.5 volt battery can produce more voltage than a solar cell. If we need more voltage, we have to combine so many solar cells. It can produce a module or array. Basically, what is a single solar cell? A PN type semiconductor, PN type diode. See, what is the physics behind this solar cell? We know that what is a P-type material, what is a N-type material. Here, we are having N-type material. This N-type material, this blue color, N-type material is nothing but a fourth group element mixed with a fifth group element. This N-type material has excess electron. In this N-type material, we have only neutral atoms. This neutral atom, P-type material, similarly fourth group element mixed with third group element. All the atoms are in neutral form only. We can say that in N-type material, electrons are charge carrier. In P-type materials, holes are the charge carrier. This N-type region, we can consider this N region as neutral atom, N region as a positive nucleus and one excess electron. The fifth group element, one excess electron. That is the charge carrier. We think like this. N region is nothing but a positive ion core and electron. Similarly, P region has a negative core and hole. Hole are positive charge as a carrier. So what happens when we combine these two materials? the charge carrier diffuses up to some particular range. After that, there is no diffusion. Then the positive core and a negative core just refuses or just repel the electron hole diffusion through the junction. So it produces a field. We call that as a depletion region. That depletion region creates a field. At this point only, our quantum perception plays an important role. Let us see that concept in detail. To develop the existing technology, we need to rectify the drawbacks and achieve maximum efficiency. So, this can be fulfilled by quantum mechanics. By how? Actually, this depletion region creates some field. We say that as a potential field. In electronics, we say that as an electric field. In quantum mechanics, we are saying this as a potential barrier. Actually, when we are forward biasing or reverse biasing, we have to overcome this electric field. In quantum mechanically says that we can say that we have to overcome this potential barrier. So, as an engineering student, you are all probably wondering that why we are going to learn about quantum mechanics. The fundamental principle behind all modern technology is based on quantum mechanics. This quantum concept helps us to handle this solar cell effectively. Understanding quantum is not as easy as you think it is. We should have some pre-ideas. That is why I have given some pre-ideas how this potential barrier or a step potential or a particle in a box like this physical problem can be overcome. These physical problem can be overcome by Schrodinger equation. So theoretically, we can calculate this potential barrier, depth of the potential, or we can say that as a theoretically, we can calculate the value of this potential. So depending upon this value, we have to apply the external potential. But in practice, on technology side, we can apply or we can increase the external voltage step by step. This may affect the original material like the p-type or n-type semiconductor. Applying more potential will destroy the material. Applying lesser potential will also destroy the material. So we have to apply exact external potential. So at this point only, our quantum concept plays an important role. So what we have to do, see here, when solar panel is exposed to sunlight, the light energies are absorbed by the semiconducting material. So the sunlight only overcome this potential barrier. Due to this absorbed energy, the electrons are liberated to produce the external DC current. The DC current is converted into AC current by an inverter for different applications that we know. To improve the efficiency of the solar cell, it uses quantum well and quantum dots as the absorbing photovoltaic material, thereby harvesting multiple portions of solar spectrum. So how at this point, how this is possible or how this solar well is formed? Let us see here. Multiple quantum wells are formed. First of all, what is this quantum well? How this quantum well is formed in a solar cell? Actually, let us see the topic one by one. What is a quantum well? Quantum well is nothing but a low bandgap material is surrounded by a wide bandgap material. So see here, a p-type material, n-type material. See this picture, p-type material and n-type material. In between this one active layer. This active layer, this p-type material and n-type material is mostly a semiconductor, silicon semiconductor, lightly doped with fifth group element and fourth group element. Here fifth group element and fourth group element. This active layer has a low band gap. So when we make a thin film of this active layer, what happens? It forms a quantum well. See here, see this picture. This picture is a wide band gap material. This picture indicates a low band gap material. So when we combine these two material, see here, this is a P layer. You just assume that this is a P layer. Then this is the active layer. This is a wide band gap material. This is a low band gap material. When we combine this, it forms a quantum well. How it forms a quantum well? See this picture. P-type material, I said, indium gallium nitride. Like this, gap is formed. We say this as a quantum well. What is this gap? How can we see this? This 10 image gives the complete details about the formation of quantum well, multiple quantum well in solar cell. So actually, what happened when this quantum well is formed? Different layers of, see here, when different layers of quantum wells are formed, the sun spectrum, solar spectrum formed on a, solar spectrum is made to incident. See this picture. The solar spectrum is made to incident on this portion. Then depending upon the wavelength, or depending upon the voltage, or depending upon the current it produced in this region. See here, what happened? This is a P-type material, N-type material, this is a P-type material. When it combines, it forms a depletion region. It creates a potential. We say this is a potential barrier. Similarly, the active region, the P-type layer, it creates a potential barrier. Depending upon the solar spectrum wavelength, the solar spectrum creates some photon energy, or otherwise we say that as a charge carriers. That charge carriers has to overcome the potential depth it formed. So different potential wells are formed. So these different potential well can be overcome by the charge carrier produced by the solar spectrum. So a wide range of solar spectrum can be utilized by the solar cell. Basically, we know that power is produced only at a daytime, not by night time or at a evening time, or at a, during rainy days we can't produce. But because of this multiple quantum well, we can generate solar energy at any time by overcoming the different potential barriers. And how this solar cell generated from the beginning? The first generation of solar cell, single junction silicon cell. This is nothing but a pure crystal solar cell is formed. How this pure crystal solar cell is formed? A P-type material, N-type material, in between this active region, I said. This active region, instead of this active region, they put a pure silicon crystal. So because of that, they generated voltage from the solar energy. This is the first generation. Its cost is very high because pure silicon solar crystal is very difficult to make. That is why its cost is very high, and also its the formation or construction is very complicated. That is why in earlier days its cost was very high. Then the second generation of solar cell coming to play, that is the thin film solar cell. This new material improves its efficiency as well as reduces its cost. The thin film cell use only 1% of expensive semiconductor compared to the first generation. Then it means that the first generation gives 100% expense. The second one only 1%. That is why the second generation solar cell cost reduces to 99% from 1977. The third generation, that is a multiple junction solar cell, our quantum well, multiple layers of quantum well solar cell. The current research is targeting only to 30 to 60% conversion efficiency while retaining low cost and manufacturing techniques. What is its efficiency compared from the beginning? monocrystalline silicon, that is the first generation, has only the efficiency of 14 to 17%. The second generation, 13 to 15%. The third generation, amorphous silicon, 5 to 7%. What is that? Nowadays, our aim is to make only high efficiency, but the third generation gives only 5 to 7% efficiency. It means that what happened? Whether we are going in a right way or wrong way. We are going in a right way only because the production cost is very, very less. That is why it occupies a larger space. Amorphous silicon is readily available, easy to make. Everyone can, there are so many manufacturers for producing the solar panels. But the first generation is very difficult to make. Its efficiency is the third generation solar cell. Efficiency is reduced, but cost is economical. So what is our aim? Our aim is to increase the efficiency. How can we increase the efficiency? By using a readily available material, we can increase the efficiency by applying these quantum concepts. So research is going, see here, the research is targeting only to obtain 30 to 60% efficiency only. So what are the factors affecting solar cell performances? Light intensity, light wavelength, angle of incidence, surface condition of solar cell, temperature on solar cell, etc. What may be the future applications? Organic solar cell based on photosynthesis in plant, use of light sensitive dyes, cost of manufacture is decreased by 60%, and also new alloys. Alloy is best. That is why new alloys, indium, gallium, and nitrogen, converts full spectrum of sunlight from near infrared to far ultraviolet. Researchers are going in this field only nowadays. I think we ended up this topic. Any queries? Thank you all.
Hi everyone, this is Dr. Lata sharing the anchoring part of today's session. Now, I'm happy to meet all our students in a new venue of the seminar. And I feel that the session is so special and close to our heart, as good old faculty of our institution has dazzled up the virtual dais of first year campus again after a decade. Ma'am, it's nice to see you and hear your voice.
Hi.
Hi. Ma'am, could you please wave your hands and say hi so that our friends and faculties of first year will replenish the good old memories. Hi, ma'am.
Hi, all of you. Hi.
Yeah. Thank you, ma'am. And it was credible and curated information on solar cells. And now, coming to your slide presentation, it was a fantastic color slides that you have shown to us in order to link the dual nature of light. It was very awesome that we'll never forget how the light is playing in a dual nature way. And you have shown one more slide that quantum mechanics is related to a woman, and that is also a wonderful example. People will never forget this. Thank you so much, ma'am. And I hope so that our students have got new insight into science terms like one-dimensional potential well, then Schrodinger wave equation, then what else, quantum theory, energy gap, forbidden gap, and so on. And don't worry, all these terms will become familiar as all your physics teacher touch unit 1 and unit 2. And now I say that it's like a journey, a long journey now, which was ended very shortly, very curated. Like you started from light, their characteristics, their perception, and slowly you entered into quantum wells, and you touched upon the solar cells, and thereby linking the quantum wells also. Thank you so much, ma'am.
Thank you, Lata.
And yeah, thank you, ma'am. And in fact, in last week, we celebrated our first year BTech. We celebrated environmental celebrations on the theme ecosystem restoration. And today, I feel that our students learned about the perception of solar cells and their importance, which is a renewable source of energy, which can harvest the biggest solar power, solar energy, and hence paving way to restore the ecosystem. I hope so. The session is so beneficial. And now we turn the platform towards question answer session. Ma'am, I hope we can handle a few questions.
Pleasure. Yeah, with pleasure.
And here's a question from Sumit Raj of L section. He wants to know how to produce photovoltaic wave. Photovoltaic wave.
I will show the slide now. See here, unspecified light source. I said solar wave can be produced by solar spectrum. Unspecified light waves produce photovoltaic waves. That is the only difference.
And thank you, ma'am. Let's search for any other question. And there is a question from Manish. Where exactly does the photon absorption takes place in the PN junction or in a solar cell, and why?
See this picture? I think would you all able to see this slide?
Yeah, yes, ma'am.
See this picture? This region, this is a single solar cell, P-type and N-type material. This region, this black portion is nothing but a conductive strip for connections. The remaining regions produce. The remaining region, only solar cell is made to incident on that. Throughout this region only solar energy can be produced. Are you satisfied with that?
Ma'am, you are muted, ma'am. Lata ma'am.
Lata?
Yeah, yeah. Yes, ma'am. Yes, ma'am. I hope that your answer would satisfy him. Now, here is a question. I would like to ask you, since we are running out of time, we'll be winding up the session with two questions. Ma'am, we have crystal defects or imperfections, right, ma'am? The presence of crystal defects in a crystal.
1 minute.
Yeah.
1 minute.
Yeah.
1 minute. I will explain this concept a little bit in detail. See here. This is the ordinary PN junction diode. Where this solar energy is produced, he asked. Actually, you consider this concept. When P region and N region are joined together, what happened? There is a depletion region formed. This electric field is produced. We call this as a potential barrier. So when we are forward biasing this or when we are reverse biasing this, what happened? The electron and the holes diffuse through. If we are forward biasing this PN junction diode, then what happened? Diffusion current is produced. If we are reverse biasing this, then drift current will be produced. Diffusion current produced by electrons. Diffusion current passes through the depletion region. Drift current, it moves away from the depletion region. So throughout this region only the charge carriers are produced depending upon the biasing we are applying. Forward biasing, the charge carriers just passes throughout this region. Reverse biasing, it moves away from the depletion region. So throughout this p-type and n-type region only, charge carriers are produced. That charge carriers only constitute current. Similarly, in a p-n junction diode, what happened? The solar energy is made to fall, or the solar energy made to overcome this field or potential barrier. So throughout that region means, see here, throughout this region only, see here, this is the connection. Throughout this region only, solar energy is produced. Is it enough?
Yeah, yes, ma'am.
Are you satisfied?
Yeah, he
Manish?
would be, ma'am, definitely. Yeah, Manish would be satisfied, and he's stacking his questions in the chat box. Now, I have my own questions. Just two questions as we are running out of time. Ma'am, there are crystal defects and imperfections in a crystal, right, ma'am? Do they play a role, or they impact the solar efficiency, or they affect the efficiency of solar cells?
See, we should know one. First of all, we should have one clear idea about this defect. If we are adding purposely impurity to the material, we say that as a doping. If it exists in nature, that is default. So, doping definitely enhances its efficiency, but a defect completely destroys the material. Doping and defect is different.
Yeah, thank you, ma'am. And here is the last question. Being a physics professor, your valuable advice, rather than advice, I have to say it as a tips and tricks, because people don't like advices. So tips and tricks for first year students on engineering physics.
Of course, we know that pure science is meant only for getting knowledge. This knowledge is not enough for satisfying our practical need. But engineering, that is technology, satisfies our human need. Without knowledge, we cannot handle them effectively. So both are dependent. Without knowledge, we cannot handle the technology. With the technology alone, we can enhance our need. So both are dependent. On my perception, both should be needed for a student.
Yeah,
you can't
yes,
escape from the theory.
Yeah, because students will have the feel like, when I get past +2, I'll get escape from physics and chemistry. But it's not like that. Even if you become a successful engineer, you should know, if you take any material property, the answer comes only from the science first. Okay, so it's like balancing. You have to balance both science and engineering. So thank you so much, ma'am, for your explanation. And now it's time. Thank you, ma'am, for clarification. Yeah. And I would like to say thank you so much, ma'am. And the chat box is flooding with appreciations for your clarification. Thank you, ma'am. And now it's time. Yeah. And now it's time to spring up all our appreciations to our chief guest in the form of certificate. And now we request Aparna to display. And a cordial request to our speaker, ma'am, to accept the same.
Thank you, with pleasure. I
Yeah,
just
thank you, ma'am.
recollected that pleasant days, what I spent in India.
Yeah, that never comes again, ma'am. Okay. Thank you, ma'am. Thank you so much.
Definitely. Thank you.
And important announcement to our students. Attendance link will be posted in the chat box, and you're requested to fill the same in order to get your attendance. There are some magic words which bring smile on our face, isn't it? One such is saying thank you. And now we have Miss Maheshwari, Assistant Professor of CSE Department, to express oath of thanks. Maheshwari, please.
Am I audible, ma'am?
Yeah, yes, ma'am.
Yeah. Good morning, one and all present here. I deem it's a great honor to propose the vote of thanks to all who have helped us in this making this webinar such a resounding success. First of all, I would like to propose my hearty vote of thanks to our founder chancellor, Dr. A.C. Shanmugam sir, our beloved president, Engineer A.C.S. Arunkumar sir, Vice Chancellor, Dr. S. Geeta Lakshmi ma'am, Joint Register Academics and Admin, Dr. V. Cyrilraj sir, for providing us the opportunity. On behalf of Dr. MGR Education and Research Institute, BTech First Year Campus, I extend a hearty vote of thanks to our chief guest, Dr. G. Mangalam ma'am, who spared her time to grace the occasion and made the webinar more interesting and meaningful. I would like to thank specially our Dean Engineering and Science, Dr. N. S. Shubhashri ma'am, for her moral support and guidance through this program. And I express my gratitude towards various committee members who have made this webinar a grand success. A special thank to the technical crew for the support. Finally, our wonderful participants who have turned up in a great numbers. Thank you for your cooperation. Thank you all. Stay home, stay safe.
Thank you, Maheshwari ma'am. And once again, we thank our speaker ma'am for readily accepting our invitation. We also thank all our participants, and a big thanks to Aparna and Saravanan, Aparna of chemistry department and Saravanan of mechanical department for their unwavering support as a technical team. And thank you and goodbye. We'll meet with yet another interesting program in coming days. Thank you. Thank you all.
நாளை நமதென்று சொல்லுவோம், நல்ல பாதையில் செல்லுவோம். கல்வியே கண்கள் என்றுமே புது தலைமுறை நம் பெயர் சொல்லுமே.
Dr. NGR Educational and Research Institute, University, Mother of all, Chennai.